What's up, everybody? So, I decided I'm gonna go about this a different way, right? Last lecture or last YouTube tutorial was about an hour, so I decided that I'm gonna start making. Instead, I'm gonna make videos for like 10 minutes where I describe a quick concept, and yeah, and that's what it is. Maybe showing an example or showing an example in a different video. So. All right, so if you were to look to the left, you'll find like what I think I would be putting in all these tutorials. I'm still working on it, but I'll just take it easy one by one, and then we can see from there how it goes. So today's topic is degrees of freedom. So that's actually going to be a very important topic for moving forward. So degrees of freedom is how free is the object to move, right? So let's say I have an object, right? This is not the best object, but let's say I have this object, right? Right now that object is free to move this way, right? It's free to move this way, and it's free to rotate, right? So this is a 2D object. So what I'm getting from here is, for 2D objects, right, it looks like I have one, so I have X, Y, and theta, right? So I have 3 degrees of freedom for 2D objects. Okay, so let's consider something else, right? Let's consider a rigid body, right? So now I have my movement 1, 2, 3, right? So this way, up and out of the screen, right? And I also have an angle going this way, right? And an angle going this way, and an angle going this way. So I can rotate this way, right, or in and out of the screen. So if you were to look at all of this, right, so that means my 3D body is going to have a 6 degree of freedom. Okay, so that's in generalized, that's free, unconstrained, right, out of control. You're just leaving it somewhere in space, and for the body as a whole. You can get into more degrees of freedom, like if you would depict different things, but I'm just saying for this body as a whole, you would have 3 degrees of freedom for 2D and 6 degrees of freedom for 3D. Okay, so if I want to generalize this, how do I say this? Well, if I want to generalize this, I would come and say my degrees of freedom is equal to, so this is degrees of freedom for object I, right, is equal to 6 degrees of freedom multiplied by my rigid bodies, right? I apologize. So this is degree of freedom for system I. Okay? So it's going to equal to 6 degrees of freedom for a 3D body, right? So how many rigid bodies I have, right? So for each rigid body, I'm going to have 6 degrees of freedom. And I'm going to add, okay, so how many 2D bodies do I have? So 3 times 2D bodies, so I'm going to call them planar bodies, right? Minus whatever constraints going on them. For example, let's say I have this box here, right, sitting on a plate, right? And I have another plate up here, just to apologize, the pad, I'm not very good at it. So I have a box, I have top, bottom, right? So that body basically can't move in this direction, right? And it can't rotate either because it got constrained. So it can only move up and down. So that is a 1 degree of freedom body, right? It can only move in this direction, right? Which is the X direction. This is just me saying no. No movement in Y direction, so no Y. Okay, so this is very important to us because the system is a collection of the degrees of freedom of each of the bodies inside of it minus the constraint, right? So this is my equation. Okay, let's go real quick to some examples. So first I have this body here, right? So this is some body that, let's say if I give it a force this way, it'll be moving this way. Okay, well, can this body move in up and Y direction? From the looks of it, it's good to assume that, okay, you know what? No movement in the Y. This body is not going to move in the Y direction. So no Y. Okay, can this body rotate? Well, from the looks of it, there would be no theta either. So from what I come here and say for my equation for degree of freedom, right? So my degree of freedom for the system is going to equal to 6 times rigid bodies. I don't have any rigid bodies. This is a 2D body, so it's going to be 0, plus 3 planar bodies. Okay, I have one planar body that's capable of 3, minus the constraints. Okay, so my constraints, I said it can't go into y, right? And it can't go into theta. So I have 2 constraints, right? So overall it's going to be 3 minus 2 is equal to 1 degree of freedom body. Great. Moving next. So I have some rigid body in space, unconstrained, right? I have some planar body, right? Unconstrained, can move in whichever way it wants, right? So this body here can move up, right? Can move down. It can't move out of the screen, right? Because I'm looking at it from a planar perspective, but it can do some theta. So when I write my degree of freedom here of the system, it is going to equal to 6 times how many rigid bodies, in this case there isn't. Planar bodies, I have one planar body. Is there any constraint? No, there is no constraint. So my total degree of freedom is 3. Awesome. Moving forward, another example. All right, well, I have some cube somewhere in space. So look at that cube. That cube can actually move right in this direction, right? This direction and this direction. So it can move in all 3 directions, and it can rotate about this axis, rotate about this axis, and rotate about this axis. So it's a free rigid body. So again, my degree of freedom in the system is going to equal to 6 times how many rigid bodies? I have 1 rigid body, okay, plus how many planar, right? I have 0 planar, so 3 times 0. And how many constraints? I don't have any constraints, so this is 0. So my degree of freedom in this system is 6. Okay. All right. My last example is a cylinder. Okay. So this is a rigid body. So for analysis purposes, I'm going to assume that that cylinder is on a shaft, right? So it rotates about a shaft, and I'm going to assume it also can move up and down, right? So my degrees of freedom is going to be how many rigid bodies? Okay, I have 1 rigid body, cylinder, right? How many planar bodies? I don't have any planar body, right? Okay, so how many constraints do I have? Well, let's try to look at this, right? Okay, can it rotate in this direction? Yes, it can. All right, what can't it do? Well, it looks like it can't rotate about this axis, right? It can rotate this way. So that's one constraint that I know of. Okay, can it rotate this way? Can it rotate about this axis? No, it cannot. So I have 2 constraints, right? It can move up and down, but it can't move in the x direction, and it can't move in the y direction. Therefore, I have 4 constraints. So that rigid body does have 2 degrees of freedom. All right. Well, I hope that was good. Please let me know if you have any questions. All right, and thank you very much.